Not long ago, a pal of mine showed me his new garden. I said, that's not bad. But I'd build another of those shady thingies if I was you. It gets pretty hot in your garden in the summer. And anyway, where are you going to put all your stuff for the garden? You need a garden shed, pal. Build one of those pergolas and a garden shed. With SPAX, of course. First, we position the supports. Dependent on the subsoil and the load, the post supports are anchored with heavy-duty dowels or concreted into the subsoil. The SPAX post screws are particularly suitable for securing lightweight joist hangers. Adjusting screws should be used on heavy H-beams. Looks pretty good. The framework is the most important bit. It has to fit just right. We place the purlins onto the finished support. However, as we have no beams in the required length of 5 meters or more, we have to connect 2 beams end to end. Specialists call this jointing. To do this, the beam ends are notched, so that the 2 ends can be fitted onto each other accurately. A heavy roof load means a risk of the purlins cracking open at the point where we have the cross-section. To prevent this, we reinforce the beam cross-section at this point using SPAX Inforce 6x80. The SPAX Inforce works like a reinforcement and prevents the beam from breaking open. We secure the joint using SPAX Inforce 6x80. Man, it's really something. All those things you can build with SPAX. Now the purlin is secured to the supports. Using a SPAX high force, the purlin and the support are pulled tightly onto each other. We then reinforce this connection with SPAX Inforce. The continuous full thread on the SPAX Inforce claws its way further into the wood with each turn, thus locking our connection. The SPAX Inforce is set crosswise, diagonal to the support grain direction, at an angle of 30 degrees. Whoa, that's a bit too much all at once. Can you explain that again? All right. The SPAX high force presses 2 components firmly together. As soon as the last thread grips into the upper component, the SPAX high force flat disc head presses the lower component onto the upper one tighter with every turn. Like a vice. Okay, I get it now. But what was that with the 30 degrees? We've used the SPAX high force to press the 2 components firmly against each other. Using the SPAX Inforce, the connection becomes sturdier and can carry higher loads. To do this, we place the Inforce at an angle of 30 degrees to the grain. You can also call that 11 o'clock or 1 o'clock. Always ensure that the screw is turned in the correct direction and that it is sufficiently far away from the edge. Over to you, Connie. Let's start with the SPAX high force. Apply nicely in the center and off we go. As you can see, the disc head pulls those 2 beams really tightly together. That's why it's called high force. We used to have iron brackets for that, but SPAX has got the Inforce now, and they hold just as well as iron brackets. Maybe even better, and I'll show you that now. To do this, we'll start at one side, apply it straight, screw it. Once it's started to grip, a bit to the side of the correct angle to the other screw, and off we go. Look at that, like a knife through butter. Now the next one, hold it roughly in place, apply it straight, Swivel it over and in it goes. Okay, now we'll test it a bit. Nothing wobbling here. Solid as a rock. That's gonna last for all eternity, that is. We can then screw a strap onto the freestanding front support using two SPAX high force 8x180. That looks good and secures the sides of the construction. Whoa, we're getting all a bit professional here. Now we lay out the rafters. There should be a 60 to 80 centimeters distance between the rafters. To make it look good, we can take the mean of these distances. The rafters are then secured to the purlin with one SPAX high force 8x240 each. SPAX high force is like a vise, a tool you might say. Pergola's done. That was quick. I'm just wondering how the hut's gonna fit in. The hut is paneled with shuttering boards. We place bars between the support beams as a support surface for the shuttering boards. In order to secure the bars, we select the correct length of SPAX high force. This connection is then reinforced with two SPAX Inforce 6x12 each. The SPAX Inforce can be applied from the top or the bottom. Once all the bars have been positioned, we can start with the boarding. We need a gradient of 2% for the roof, meaning a 2 centimeter gradient per meter roof surface. Now the shuttering boards are put into position and secured with SPAX A2 countersunk heads. The screw sinks in cleanly and without causing cracks into the SPAX 4-cut tip and the milling pocket below the head. That's just what I said, top-class surface with no cracks. Projecting shuttering timber is capped using a jigsaw. Now the roof surface is boarded. To do this, we take SPAX rust-proof 5x60.